good morning. This lesson is going to attempt to cover adding and subtracting radicals in one lesson because they actually do exactly the same thing. So it's like adding and subtracting the way you would normally add or subtract. And the piece that has to do with the radical, there's nothing different at all between the adding and subtracting. So the goal is to teach it once and then be able to apply it twice. And then what we'll do is we'll take a day to kind of review and practice all of our operations with radicals. So as we talk about adding and subtracting radicals, there's a key idea, and I want to tie this back into our vocabulary. So we have a key idea, and that is this. You are going to treat the radical like a variable. Now, hopefully that makes sense, because if you think about a variable, what is a variable? We'll kind of do a little definition down here at the bottom. What is a variable? It is simply an unknown number. It is a letter that represents some kind of number that we don't know what that number is. Often we're trying to find the value of that number. Sometimes it's something that actually can vary. So if it's time, your variable might be 1 second or 2 seconds, but all a variable ever was a letter that took the place of a number. So to say we're going to treat the radical like a variable is a logical thing to do. It's just now we know what the number is. So the number might be the square root of 2 or the square root of 3. And so it behaves the same way as the variable. So what do I mean by that when I say treat the radical like a variable? If you had this problem, you had 4x plus 2x, and I were to ask you what that is, I hope you would tell me 6x, okay? Now, because somebody in their head said to themselves 6x squared, I do want to address that. Somebody said it. I don't know who it was because you only said it in your head, but it was there. X squared comes from doing multiplication. And this is not multiplication, this is adding. So if you're tempted to try to pull those x's together and say x squared, what that means that you did was you added the numbers and multiplied the variables. And we definitely don't want to do that. We want to commit to one thing. We're either adding or multiplying, but we're not trying to do both at once in the same problem. What often helps students who tend to make that mistake is substitute your favorite noun in for the variable. So I always use kittens. If I have 4 kittens plus 2 kittens, I have 6 kittens. I don't have kittens squared because I don't know what that is. So 4 kittens plus 2 kittens is 6 kittens. So that's how that works. Now, when we're talking about the radicals, suppose you had 4 root 2 or 4 root 5 plus 2 root 5, you would treat that radical the same way you would a variable. So you would consider these like terms, so to speak. Okay, like terms, meaning they have the same, not variable part, but the same radicand part, and they have to match. So if I have 4 root 5s plus 2 root 5s, then I actually have 6 root 5s. Notice that you don't do anything with the number under the radical. So we have a couple things we want to make sure that we know. First of all, to review that vocab, this is called the radicand, okay? And I want you to notice that in order to add your radicals, the radicands must match. And again, we'll illustrate that in a moment. I'll give you like an example. The other thing I want you to note is that we do not add or subtract the radicands. So we don't actually, sorry about that. The radicand. Sometimes it's very hard to write and talk at the same time. My brain does not quite do that, especially after a long day at work, which I saw all of you guys at work today, and now I'm doing more work. So my brain is tired. But you don't add or subtract them. So we don't do the square root of 5 plus the square root of 5 and get the square root of 10. It's different than with the multiplication. With the multiplication you do. With the addition you don't. You will get those confused if you don't practice enough. So what's going to happen is I can teach the multiplication and the division and the adding, subtracting, and you're like, yep, I get that. That makes sense. And then when it comes to the test, you will end up using your addition rules to work with your multiplication, or your multiplication rules to work with the addition. And the only way to really keep that straight is to practice it enough to really reinforce how these problems work. So we got a couple of examples here, and we actually incorporate the subtraction in here. So here is my first example. If I have 2 root 3 minus root 3. So the variable version of this would be like 2x minus x. So just, again, you're treating that radical like a variable, and they do have to match. So if you have 2 root 3s minus, and then think to yourself, how many root 3s is that? 1. Just like with the variable, you assume that it's a 1x. Some of you guys on that polynomials test, when there wasn't a coefficient, you were telling me it was 0. It's not 0. 0 times x would be 0. It wouldn't be there. 1 times x is x. That's why it's there. I know at the beginning of the year, I spent all this time talking about ones and zeros, and there's a reason I spent all that time talking about it. So we have 2 kittens minus 1 kitten, which would give us 1 kitten, or just kitten, and we would do the same thing here. 2 root 3 minus 1 root 3 would give us 1 root 3. Remember, that's multiplication there, just simply root 3. So it works the same way. Now, our second example looks like this. If you have 3 root 3 plus 3 root 2. Now remember, our key idea is that we're going to treat the radical like a variable. So let's look at the variable version of this. This would be like 3x plus 3, and now I have a different radical, so I'm going to use a different variable. We'll have 3x plus 3y. And I hope that you notice that you cannot add 3x plus 3y. Now, we'll go back to that strategy of putting in your favorite noun. 3 kittens plus 3 ice cream cones. What do you have? You have 3 kittens and 3 ice cream cones, and that's what you have. There is no like cat who ate an ice cream cone, or like there's nothing like that. It's 3x plus 3y. And the same thing is true here. 3 root 3 plus 3 root 2. There is nothing you can do about that. So you would just answer that question. You cannot add. Or you could say cannot add. You could say already simplified, because sometimes the directions will ask you to just simplify it. Could be how it's expressed. So that's the key idea there. So I'm going to give you guys 3 practice problems, and at the time of this recording, which is like a week in advance, I don't know how I'm going to have you do these practice problems, but we're going to do something with them. So here we go. Okay, so there they are. First one, in fact, these are actually simple enough that you should be able to do them in your head without doing any work. And I don't say that all the time. So if I say you actually should not be doing any work for that, like I mean it. So 3 root 7 plus 4 root 7 minus 5 root 7. What does that simplify to? Second one is 2 root 5 minus root 5. And the third one is 2 root 6 plus 4 root 5. So I will pause the video for a moment so that you have a chance to think these through and write down the answers, and then we'll move on. And hopefully those answers match your answers. If you have 3 root 7 plus 4 root 7, that gives you 7 root 7. And 7 root 7 minus 5 root 7 is 2 root 7. If you needed to, you could think of it like this. 3x plus 4x minus 5x. Just kind of picture that variable in there. The second one is just root 5. That looks like one of the examples that I just did. So this would be kind of like 2x minus x. We just give you the x, or in this case, root 5. And in this one, you should notice that you don't have the matching radicands. And so you can't actually add those. All right, so let's move on and let's take a look at some other variation of this. What about this? 6 root 5 plus root 45. So you might be tempted to say, well, look at the radicands, and you say, okay, well, the radicands don't match, therefore you can't add them. But before you're allowed to conclude that, you actually have to make sure that all of your radicals are simplified as far as they can. If we look at all of these problems we've looked at, you cannot simplify the square root of 7, the square root of 5, square root of 6, square root of 3, square root of 2. None of those we're able to simplify. But I actually can simplify the square root of 45. So before I'm allowed to say, oh, I can't add those because the radicands don't match, I actually do need to try to simplify them. So over here on the left, we'll do 6 root 5, and then the square root of 45. 45 factors into 9 times 5. And we've done this before. So we have the square root of 9 times the square root of 5. Now what I am doing in the middle of this is I am reviewing once again how to simplify square roots. Square root of 9 is 3. And now my radicands match. Again, notice the top-down structure. You should be doing your problems top-down. Actually, this year, you guys have been really, really good about doing them top-down. So the 6 root 5, it comes down until you're ready to deal with it. Here we're factoring. We put the perfect square on the left, not because we have to. Some of you on your complex numbers quiz said that, like you had to. It's not that you have to. It's just strongly recommended because it makes the scratch work come out better. The square root of 9 is just 3. There's no more square root on it once you take the square root. And now I have 6 root 5 plus 3 root 5, which I actually can add, and 6 plus 9 is 6 plus 3 is 9. Sorry about that. So the key takeaway here is that you have to simplify the radical before you conclude that you can't add. Okay, you have to simplify everything down first before you're allowed to make that conclusion. Okay, so let's do a practice problem of this type. And there's only one practice on this, so I won't pause the video for it. The practice problem on this is the square root of 12 minus the square root of 27. So this one actually does take a little bit longer because you do have to go through the process of simplifying those radicals. So I'll pause the video and give you some time to work that out, and then we'll come back. We're actually almost done with the lesson, so this should work out nicely. And hopefully your work looks something like this. So 12 factors into 4 times 3, and the square root of 4 is 2, and of course you can't take the square root of 3, so we have 2 root 3, and then 27 factors into 9 times 3, and we can take the square root of 9 to get 3 root 3, and now the two radicands match. So we have 2 root 3 minus 3 root 3. 2 minus 3 is negative 1. Negative 1 root 3 is fine. I would accept negative 1 root 3, or you could just say negative root 3 would be fine as well. So hopefully your work looks something like that. Now, a couple other points before we leave this. You know that I'm a big advocate of basic concepts. So other types of radicals. Okay. It also works for other types of radicals. So I'm of the philosophy that rather than teach like all kinds of complicated stuff with complicated radicals, that we teach square roots really well. And you learn square roots, and then if you know square roots really well, then you'll be able to handle the other kinds of radicals, especially if, and we have done this, taught you what the other radicals mean. And so you can interpret that notation. So here's what I mean by this. If you were to see something that was like 2 cube root 4 plus 3 cube root 4, you would look to make sure that they were the same type of radical, so they're both cube roots, and the radicands match, and so we'll treat that like a variable. It's going to look like 2x plus 3x, which would be 5x, except it's not an x. It's a cube root of 4. So you've got 5 cube root 4, and please don't do that in the middle of it. That is Miss Taylor teaching, okay? That's what that is. And so everything that we've done with the square roots is also going to work for your other types of radicals. The knowledge should transfer pretty smoothly. So here's our fifth practice problem. I would like you to do 6 fourth root 2 minus 3 fourth root 2. And that should take you about 10 seconds to do. Maybe 10 seconds. And of course, hopefully you have a 6, like think of that as 6x minus 3x would be 3x, except it's not an x, it's a fourth root 2. So basically 6 minus 3 is 3, and then you just bring along the radical for the ride. My college algebra students, they have a problem like that on their first test. And every year there's somebody in my dual enrollment class that does mess it up, and they try to do something with the fourth root, and they just try to make the problems harder. So, radicals are radicals. Math is consistent. What works for a square root is going to work for your other roots, and if it doesn't, if there is some kind of weird thing, like you can take the cube root of a negative, I'll cover that in class so that you see it. But if we don't mention a whole lot about it, you're probably good to go. Now, the last thing I want to cover with you is a test taking thing, okay? And so I'll actually pause the video and write this out. And this is has to do with the tests that you guys take. You take so many tests. How do you navigate, or how can you navigate a multiple choice question if you forget? I know we haven't done tons of stuff with calculators this year. Normally, I do whole lessons on graphing calculators, and we just do a lot more. And this year, between my DHR section and the difficulty of moving like physically around the classroom, I really haven't gotten on you guys about making sure you own your own calculator. You need to own at least a scientific calculator, preferably a graphing calculator, because I have the whole menu of graphing calculator lessons on Teams, like tons of them. So, I want you to have that. And if you are taking a multiple choice test, you can leverage your calculator to help you. So let's just hypothetically, you're taking a multiple choice test and you're blanking out. You don't remember how to add radicals. You don't remember how to simplify them. You just are blanking out. What you should do is you should take the original problem and enter it into your calculator. Now, here's why you need to own your own calculator. You need to know how to use it. And they all work a little bit differently, but you need to know what buttons you need to push in what order to get the right decimal. This should come out to 3.46, and I'll have a lot more numbers out there, but 3.46 is enough to answer the question. It's not going to do you any good to have a calculator if you do not know how to use it, and you will not be able to use your phone on your final exam or on the SAT or the ACT. And people are not going to hand you a calculator to use. So you have to have one. Now, once you enter that into your calculator and you get 3.46, you should, on your margin of your paper or your scratch paper, you write down 3.46. Now you go through the other answer choices. You go through the 4 answer choices and you find out what those are equal to. Keep in mind that this is multiplication, okay? So you're going to be doing 2 times the square root of 3. On some calculators, you're going to have to do 3 square root, then times, then 2. You're actually going to enter it in the other direction, and that's why you need to practice. And all the calculators are different, so it's not like I can do a lesson. Like I can help you out individually, and if you're a DHR student, I'm willing to meet with you online so we can go through how to use your calculator, but they're all different. When you do this, the square root of 36 is 6. That was terrible. Let's try that again. 2 times the square root of 3 is 3.46. That looks promising. 3 times the square root of 2 is 4.24. Not the same thing after all. And square root of 12 is 3.46. Okay, which leaves us with a little bit of an issue. We know that one of these has to be the correct answer choice because it has to be equal to the original problem. The problem is I got 2 things that were both equal. So let's take a look at each of them. And B has an advantage over D because B is simplified. And we know that 12 is not simplified because we just did it. Okay, we simplified the square root of 12. So we know that that's not simplified. We actually know that when it simplifies, you get 2 root 3. If you do your practice problems, if you do your homework and you do enough practice work, you'll notice the same square roots keep coming up over and over and over again, like the square root of 8, the square root of 12, the square root of 27, the square root of 48. Like, they just keep coming up. If you do enough practice work, you'll almost memorize what these are. But you would pick answer choice B, and you can actually get there without remembering anything about your square roots. So last practice problem of the lesson is this one. What am I up to? Practice problem number 6. Okay. And it is the square root of 45 minus the square root of 80. And here are your choices. Negative square root 35, square root 5, negative square root 5, and what is this? Negative square root of 20 over 5. And I will stop the video here, and we'll talk about it in class, or I don't know what else we'll do, but I'm stopping the video here.